Hello everyone, we are meeting once again for Double Integrals Part 2. I am Dr. Krishna Prasad, Professor in Mathematics Department of H&S, MLR Institute of Technology, Hyderabad. In the last class actually, we studied Double Integrals Part 1. In that part actually, we studied about how to evaluate the double integrals when the limits are given and when there are variable limits. So let us go to the next part. Now in this, first of all, let us try to discuss about the polar form of double integrals. Whenever the double integrals to be transformed into polar, you know very well there is the equation of the circle. The equation of the circle we know very well. It is x square plus y square is equal to a square. Now this equation of circle, whenever there are circular regions or equation of a circle is visible in double integrals, we convert to polar form. Now what are the transformation equations? They are x equal to r cos theta, y is equal to r sin theta, and the inverse transforms are given by r is equal to under root x square plus y square and theta equal to tan inverse y by x. And we have to make sure that the area element dx dy has to be converted into polar form, that is r dr d theta. So this is the thing you have to keep in mind. Dx dy is equal to r dr d theta. So in view of this, now you can see that the double integral that is there in the Cartesian form, y is equal to phi 1x to phi 2x, x is equal to a to b, fxy dy dx is equal to, now we got double integral in polar form, f r theta r dr d theta. See that. And then the limits are, now inner one r is equal to 0 to a, outer one theta equal to alpha to theta equal to beta. So it is something like this. Now if you got a circular region like this, and now you take a strip like this. So this is a P and this is a Q, and this circle is nothing but r is equal to a. So the starting point here r equal to 0 and the ending point is r is equal to a. And if you see the angle, actually this from this angle is theta equal to 0 to theta equal to pi by 2 for a quarter circle. Now let us see further. Now let us take a first example, very simple example here. You have to evaluate this double integral r dr d theta. R is equal to 0 to a sin theta, theta equal to 0 to pi. So the limits are already given. Only thing you have to evaluate this. For this, what you do is that first of all integrate with respect to r. What is that? R square by 2. And then put the limits r equal to 0, a sin theta, and then d theta as it is. Next, theta equal to 0 to pi. So for this, now what we get? Put r is equal to a sin theta, a square by 2 sin square theta d theta, theta equal to 0 to pi. Now a square by 2 being a constant, we will take it out, and then sin square theta convert into multiples. 1 minus cos 2 theta divided by 2, and then integration 0 to pi. Now it is a square by 4 because 1 by 2 will be out. One integration is theta minus cos integration minus sin 2 theta upon 2, theta equal to 0 to pi. Now before applying here the limit, see, upper limit is pi, lower limit is 0. So clearly sin 2 pi 0, sin 0 0, therefore this will go to 0 completely. I repeat once again, sin 2 pi is 0, sin 0 is 0, this second term is vanishing 0, and hence you are left with the constant a square by 4, theta limits pi minus 0, and we arrive at the final answer a square pi by 4. So that is how you have to solve the first example, very simple one. Nevertheless, next one. Now, this one, if you see, actually this is more complicated here. Evaluate integral 0 to 2, integral 0 to under root 2x minus x square plus y square dy dx. Now, in this case, actually, if you see carefully, the inner one is with respect to y, outer one is with respect to x. Because it's a circular region, you have to convert it to polar form. It becomes easier. So, if you take this, the top limit y is equal to under root 2x minus x square, try to rearrange the terms, then you get x square plus y square minus 2x equal to 0. Clearly, if you complete the squares, it's a circle. Center is 1, 0, radius is equal to 1. And the lower limit of y-axis is 0. There is x-axis. You can see here. You can see there. Now, let us convert the whole thing into polar form by taking the substitution x equal to r cos theta, y is equal to r sin theta. Then, x square plus y square minus 2x. X square plus y square. X square plus y square is r square minus 2x. 2r cos theta equal to 0. Now you solve this, you get r is equal to 2 cos theta. So that is the equation of the circle in polar form. So what are the limits basically? So this is the region you are looking at, the diagram, see the diagram here. So basically the region is upper half of the circle. Upper half means what are the limits now? If you take a arrow, r is 0, r is 2 cos theta. And what is here? Theta equal to 0 on the right, theta equal to pi by 2 on the left. So the limits now, okay, after conversion to polar form, the limits would become the limits of r equal to 0 to 2 cos theta, limits of theta equal to 0 to pi by 2, 0 to pi by 2. Remember, it's not 0 to pi because you have to see the angle there. Theta equal to 0, this line, theta equal to, and this. So this is what I am trying to say is this. So this is theta equal to 0 and this line is theta equal to pi by 2. If you convert the whole thing into polar form now, what you are going to get? See, let us see in the next slide. So this is a given double integral. Now this double integral now is converted into polar form. As we have discussed, the inner one r equal to 0, r equal to 2 cos theta, and outer one theta equal to 0, theta equal to pi by 2. And x square plus y square is clearly r square, and dy dx, this area element will become r d theta dr. Okay, now the outer limit is same, 0 to pi by 2, d theta, take it out, no problem. And now r square into r is r cube. R cube integration r raised to 4 by 4, and the limits are 0 to 2 cos theta. Now once you apply the limits now, naturally what you are going to get is 2 raised to 4. 2 raised to 4 is 16. R raised to 4 divided by 4. 2 raised to 4 divided by 4 equal to now 16. 16 by 4 equal to 4. So this is 4. Integral 0 to pi by 2 cos raised to 4 d theta. So the main thing is now how to evaluate cos raised to 4. So there are two ways here. The first one is convert to multiple angles. The second way is that you can use beta gamma functions. Okay. Now let me tell you how to use that beta gamma functions, beta function formula. We know very well 0 to pi by 2, sin raised to m, cos raised to n, d theta. This is half beta m plus 1 by 2 n plus 1 by 2. So this is a formula. And second formula is beta mn is equal to gamma m gamma n divided by gamma m plus n. So this is how now you can convert sine powers or cos powers into beta and gamma functions. So let us see now cos raised to 4. What happens to cos raised to 4? So now cos raised to 4 integral cos raised to 4 theta d theta 0 to pi by 2. This will be now half beta. Sine power is 0 here. So 0 plus 1 divided by 2. Cos power. Cos power is 4. 4 plus 1 divided by 2. So this is a half beta 1 by 2 5 by 2. Half gamma 5 by 2 upon gamma half plus 5 by 2. So now you know very well gamma half is root pi and gamma 5 by 2 reduction formula 3 by 2 1 by 2 into gamma half root pi and 5 plus 1 is 6 by 2, gamma 3 is 2 factorial. So if you simplify the whole thing now, what you are getting here, this is a 3 and this is a 2, 4, 8, 16 into pi. So this integral is nothing but 3 pi by 16. Okay, now that 4 cancel and what you get is 3 pi by 4. That is the answer. Now you can appreciate the use of beta gamma functions here because see the power may be more. It may be cos raised to 6, cos raised to 8, cos raised to 10. And then it's difficult to convert into multiples of angles and then evaluate. Instead use beta gamma functions. So let us start now the example number 3. We already seen example 1 and 2. And example number 3, if you see the integrals now, it is y limits are, lower limit is 0 and the upper limit is under root 2x minus x square and outer limit x equal to 0 to 2. The moment you see this, you can immediately realize that it is a circular region. If it is a circular region, change it to polar coordinates. If you change the polar coordinates, the double integral becomes much easier. Remember that. So it's always a point to be noted that depending upon the region, try to change the coordinates. Cartesian to polar or Cartesian to cylinder, Cartesian to spherical polar, etc. etc. Okay, now this region we already seen. It's a upper part of the circle. Y is equal to under root 2x minus x square. In the last slide, we have seen this already. You can see there. Same thing I have taken up so that you will recognize that limits. So in view of that previous example, so let us see this region once again. So this is a Cartesian coordinates picture and this is a polar form picture you can see. Now here in the Cartesian form we have taken a vertical strip and this vertical strip actually will give rise to these limits, but you want to change it to polar. Once you change it to polar, naturally you want to take up this figure, upper half of the circle. Now I told you already, you have to take a ray starting from r equal to 0 and ending, the ending point here. The ending is r is equal to 2 cos theta. So the r limits are 0 to 2 cos theta and theta. The theta starting point is 0 and ending point from here to here anti-clockwise is positive. So theta equal to 0 to pi by 2. So once you understand these limits, now go to the next one. So the given integral is converted into this form. So what are the limits? This is r equal to 0 to 2 cos theta and next theta theta equal to 0 to pi by 2. Next, now try to convert that. Integrand x, that x is nothing but r cos theta. Next, this dy dx is the area element. I told you that once you convert into polar form, it becomes r dr d theta. And then finally, if you see that denominator under root x square plus y square, this becomes r. Now simplify, that r will get cancelled. Limits will be same, of course, r cos theta dr d theta. So that is what you have to integrate. So first, you have to integrate with respect to r. If you integrate r, the integration becomes r square by 2. The limits are 0 to 2 cos theta. Cos theta is constant with respect to r. Take it out and now put the limits. So what you are getting, cos theta, if you see cos theta into r square by 2. R square by 2 is 2 cos theta whole square divided by 2. So if you see this now, 4 into cos square into cos. 4 cos cube divided by 2. 2 cos cube theta d theta. Now, cos cube theta. So this is nothing but actually 2 times 0 to pi by 2 cos cube theta d theta. Once again, we come back to the same thing. What is that? How to evaluate that cos cube theta 0 to pi by 2 cos cube theta d theta. How to evaluate? You know very well, this is a half. Sine power is 0. So therefore, it is 0 plus 1 by 2. And cos power is 3. 3 plus 1 by 2. Half beta half 2. Convert to gamma. Beta m comma n. Gamma m. Gamma 1 by 2. Gamma n. Gamma 2. Half plus 2. 5 by 2. Now simplify this. Okay, if you simplify this, half, gamma 2, gamma 5 by 2. Now use reduction formula for gamma 5 by 2. Gamma 5 by 2 is 3 by 2, 1 by 2, gamma half cancel. And then gamma 2 is 1 factorial divided by 3 by 4. Now this is a 4 by 2. 2 by 3. So cos cube theta is 2 by 3. Multiply by 2, 4 by 3. That is the final answer. Okay. So the moral of the lesson is that if the region is circular, it's much easier if you convert into polar form. Okay, now let us take here one more example. Evaluate double integral xy dx dy over the positive quadrant of the circle x square plus y square equal to a square. So this example actually has been taken so that you can understand sometimes you can evaluate directly also. It's all about the integration. If the integration becomes easier or it's okay, then try to do it directly by Cartesian coordinate method. But sometimes the integrand may be very complex or tough. Then it's better to convert into polar form. So here actually it is not converted into polar form and we are trying to do directly. Of course, you can solve by polar form also and the answer will be one and the same. So if you see this now carefully, quarter circle, you take a vertical strip. Remember the part 1, you can take either vertical strip or horizontal strip. If you take a vertical strip, the lower limit will be y equal to 0, upper limit is y is equal to a square minus x square. X square plus y square equal to a square. So y square equal to a square minus x square. Now take under root both sides, y is equal to under root a square minus x square. So y equal to 0 to y is equal to under root a square minus x square. Now here x equal to 0 and the rightmost limit x equal to a, x equal to 0 to a, integrand xy dx dy. First you have to integrate with respect to y. So the y integration is y square by 2, here y square by 2, and keep x outside and put the limits 0 to under root a square minus x square. Now put the limits. So square and under root, they will get cancelled. 1 by 2 will be out. X, thus x is here. And this one will become a square minus x square dx. So it is simply x into a square minus x square dx. Now multiply throughout. X into a square by 2 minus x cube. So you can see the step here. What is happening? So here 1 by 2 integral x a square minus x cube into dx, and limits are from x equal to 0 to a. Now a square is a constant, x square by 2. So a square x square by 2, first term. Second term minus x cube integration minus x raised to 4 by 4. Put the limits. So once you put the limits, then you can simplify. So what is that now? 1 by 2 a raised to 4 by 2 minus a square 1 by 2 a raised to 4 by 2 a raised to 4 by 4. So a raised to 4 by 2 minus a raised to 4 by 4 will be a raised to 4 by 4 multiplied by 1 by 2. So you get the final answer a raised to 4 divided by 8. Okay, so now if you see here, directly we have done. By the way, if you don't want to do directly, you can convert into polar form. So let us see that alternatively how to do that. Let us rub off that and then let us try to see if you convert this whole thing into polar form, what happens? Now you have to take an arrow and this is r equal to 0, r equal to a. So minimum is 0, radius, maximum is a, and this is theta equal to 0 and this is theta equal to pi by 2. So this is 0 to pi by 2. Next, substitute for x, r cos theta. Substitute for y, r sin theta. Substitute for dx dy, r dr d theta. Now try to simplify. R. Okay, r cube into cos theta sin theta. So sin theta cos theta into dr d theta, 0 to a, 0 to pi by 2. You see that now, r raised to 3, r raised to 4 by 4, 0 to pi by 2, sin theta, cos theta, d theta. Now put the limits here, 0 to a. So what is happening now? A raised to 4 by 4. And now sin theta cos theta convert into multiples of angles, sin 2 theta divided by 2 into d theta, 0 to pi by 2. Now I am doing a raised to 4 divided by 8 sin 2 theta minus cos 2 theta divided by 2, 0 to pi. Now minus a raised to 4 by 16 cos 2 pi. Cos 2 into pi by 2 is a cos pi. Cos pi is minus 1. Cos 0 is minus 1. 2 cancel, minus minus cancel. Ultimately, you get a raised to 4 divided by 8. So this example now we have shown both the methods directly by Cartesian method and then by polar form. So sometimes you can do like that, but it's always desirable a circular region convert into polar form. Okay, now next I have given some problems for practice, not many, but of course 1 or 2. By changing into polar coordinates, evaluate the problem number 1, integrand is x upon x square plus y square. Problem number 2, integrand is x square y square by x square plus y square. Okay then, so that's all in this. We have now studied how to change the integrals into polar form and then evaluate. See you in the next part of the double integrals. Thank you.